Well, welcome to your geometric dimensioning and tolerancing lesson. And we're going to have a little bit of a transition from what we've previously been doing, and we'll be focusing on symbols that are part of a blueprint. And why you need to know this as designers is pretty simple. GDT, as geometric dimensioning and tolerancing is often referred to, acronym-wise, GDT is the language of manufacturing and industry to deal with shape, to deal with tolerances that are make it or break it moments in manufacturing. Typically, assembly. When parts are going together, think about a laptop, for example, or even a smartphone. That's a lot of small parts very, very closely compacted together. And what happens is, if it isn't manufactured to spec, or if the specs aren't tight enough to make it controlled, then you have parts that don't interact correctly or don't assemble correctly and throws the whole thing off. That is controlled by the blueprint. So that's where you come in. You're actually at the stage now where not only you're designing something, but you need to design it so that the manufacturer knows their limits in terms of tolerance. And not tolerance just by being, plus or minus 10 millimeters or something, but tolerance in terms of the overall shape. GDT is more about the shape of a part than it is just the raw numbers. So, in this lesson, you will be exposed to a lot of terms, a lot of new ways of thinking. So a lot of it's abstract in terms of what a GDT is and how it applies. What we recommend is you go through the material very slowly, making sure that you understand one GDT, perhaps perpendicularity, fully before you go on to the next one, and that you can apply it on a drawing. You know how to go in and say, okay, I've got this object that's supposed to be 90 degrees from the surface. How do I make sure the manufacturer fully understands that it's just this surface that needs to be 90 degrees versus another surface? How do I specify a datum correctly so there's no confusion on how something needs to be? And it's all up to you at this stage because you are the designer. You are the person who's making the blueprint. You are the person who's making these specifications for potentially millions of parts to be made off of your blueprint. So it's very important that you kind of get this right and get a good understanding of it. Because a lot of folks don't really understand what GDT is, and so therefore when they go to make blueprints, one of two things can happen. One, they don't specify enough GDTs and the parts are misshapen. And when I say misshapen, I don't mean like visually you can easily tell that something's off, but when it comes down to like tight fits with other objects, that's when it becomes apparent. So that's one thing that can go wrong. The other thing that can go wrong, it can be too much GDT. Too many geometric tolerances, which means the cost of the part goes way higher than it needs to be. We see this a lot in the manufacturing where designers just throw a lot of GDT at a drawing and just overdo it. And so we have a part that's not super critical, that only has about 2 points of connection that are critical, and yet the whole part is just full of extra requirements that aren't necessary, which drive up the cost. Okay? So it is crucial that you understand this because this is very much equated to money, production money. The cost of a part is highly related to the number and the correct use of geometric dimensioning and tolerancing symbols. Alright, so take your time in this lesson. We've built in plenty of time for you to actually go through it thoroughly and not rush, because we want you to have a really good understanding of this material and why it's important to you, and we provide tutorials to go with it, and make sure you do those as well. Don't want to miss this because this is a real catch when it comes to a job interview, is that folks are going to want to know how well you know GDT in terms of like their eventual design or production capability. Alright, thanks for watching, and again, be patient. Take your time. If something's a little fuzzy, let us know. And feel free to go out to YouTube and find other references for GDT to make it snap together a little bit better for you. We provided resources for your use, so take those and use those thoroughly. Print them off if you need to. Make some notes. That's a great way to learn this material. And do a lot of little sketches, maybe on your CAD software or maybe just on pencil and paper. That's the kind of thing that really makes this sink in. All right? So thanks for watching. We'll see you.